Physical RAM is the actual memory chip in your computer. It's fast, but it's limited. What happens when you open too many programs or a program needs more memory than you have in RAM? Your computer would crash, right? No. Take the example of Windows. Windows on some device take 40% of RAM for the OS to function in idle. But does it crash? No. That's where virtual memory steps in. Your operating system, specifically the kernel, creates an illusion. Every program thinks it has access to continuous large chunk of memory called virtual address space, and it's much bigger than your physical RAM. Now, the kernel acts like a masterful librarian, divides both virtual address space and the physical RAM into small fixed chunks called pages. Typically, these are 4 kilobytes in size. When a program tries to access a piece of memory, it uses a virtual address. The kernel translates this virtual address into a physical address in your RAM. This translation is done using a special table called the page table. Here's where the beyond physical RAM part comes in. If a program needs a page of memory that isn't currently in physical RAM, the kernel performs something called memory paging. It identifies a page in RAM that hasn't been used recently and swaps it out to an area on your hard drive called the swap space or page file. This frees up space in RAM. Then the kernel swaps in the needed page from the hard drive into the newly available RAM space. So the kernel is constantly moving pages between RAM and the hard drive, and this is why you sometimes hear your hard drive chugging away when you're multitasking. This ingenious system allows your computer to run more programs than would fit in physical RAM alone, prevents individual programs from hogging all the memory.